Hey everyone, thank you so much for joining in and welcome to your learning journey. And as part of this today's session, folks, we'll be looking into this concept of decision tree. Now, in the last session, we actually had a high level understanding about this decision tree. Now, as we proceed in this session, okay, we would go ahead and we would go ahead and just a second, folks. Okay, so we would go ahead and discuss about this topic of this decision tree algorithm. So that would be the agenda of this session, guys. So, folks, in the last session, let me just bring up the notebook that has been implemented in the last session. So this is a notebook that we created in the last session. Okay. So in the last session, we have looked into this understanding of what exactly is decision tree at a very high level, and we have implemented this in an hands-on manner. Now, what we'll be doing in today's session is we would go ahead and have a deeper dive into this decision tree algorithm and technically understand how we actually fit the data. Okay, how we actually fit the data. And after we fit the data, we'll also go ahead and we'll also go ahead and understand the technical details of the same. So that would be the overall agenda. So it's not just about performing the fit, but we'll focus specifically on what happens. Okay, what happens once we start the fit. Okay, that's the overall agenda of this session, guys. Now, as I mentioned already, so this session is made possible with the team at Manifold AI Learning. So Manifold AI Learning is an e-learning company who's into providing the the more trending courses, especially on this field of generative AI, machine learning operation, LLM operation, AI operation, generative AI, and there are multiple courses related to your AWS machine learning preparation, PyTorch, mathematics for AI. So we've got various topics, guys. And if you're someone who is getting started and more interested about how exactly this generative AI would work and how we can operationalize it, so one course that I would highly recommend is the course on LLM Ops Masterclass. I'll be sharing you the link over here in the chat window, guys. Do refer, do check out this link, and there's a offer that's running in. So by enrolling today, you get the 5% off on the price that you'd see on the Manifold AI Learning site. You get 5% off on the prices that you see over here. Okay, so this is a limited period offer, so grab it and get the most of this upcoming learning journey. And all the courses with Manifold AI Learning comes with 30-day refund guarantee. Now for some reason, if you're not happy with the self-paced course, you can write a ticket to the support team and they'll be assisting you with the refund if you're not happy for any reason. So that means there's no hesitation, I would say, for trying out the course, because the learning that you would get is in line with the current industry requirement. So my name is Nachiket Purte and I've got an opportunity to create the courses with them. So do check out their courses, guys. Now, as I mentioned, this is the continuation of the last session. That means in the last session, we have done the implementation at a very high level. Now we would continue further. Now, all the previous sessions recording is available over here on this link. This is the link where you can access the previous sessions recording, not only just previous sessions recording, but all the discussions that we had so far has been made available to you over here in this LMS, that is Learning Management System. If you just go to this link and click on access the learning content now, you can access all the learning content. Apart from that, it also consists of the Google Colab file. Okay, you can check out this Google Colab file that is already shared over here as an attachment, and you can get the same and take a reference of this notebook, and we'll be continuing further in our learning journey. Okay, so let's get started, everyone. Now, before we proceed ahead, so please let me know if you have any questions from the last session. If you're clear, if you think that we are good to start with today's session, please confirm by typing in as good to start in the chat window. Thank you, Rajat. Thank you, Shripad. Okay. Thank you, Dheeraj. Okay. So thank you, Lakshman. Perfect, guys. Thank you again, everyone, for joining in. For the folks who have joined through various social media channels as well as on our live webinar. Okay, thank you, Soumya. So let's proceed ahead and let's understand about this decision tree algorithm, guys. So in the last session, when we have discussed about this decision tree algorithm, we have said that, so here the algorithm is going to find the pattern between my input and output, that is between this X and Y, using a tree-like structure like this. Now the question is, how does this tree would get constructed when we have a given data set? Now, the way this tree gets constructed is with the help of the criterion function. Okay, it gets constructed with the help of the criterion function. Now, this is called as a criterion function, and some people will also call it as a loss function. So let's look into the criterion or a loss function that we have got when we are creating the decision trees with the help of the decision tree classifier. So I'm going to open up the documentation page of this decision tree classifier. So this is the official documentation page of this decision tree classifier. And if you look at it from the criterion standpoint, we have something called as Gini. Now Gini means it's a Gini impurity index. Now when we say Gini impurity index, so let's have a look into the equation. So let's search for Gini impurity index. So if we take a quick look into this Gini impurity index formula, so the Gini impurity index formula is given by 1 minus P of I square. Okay, that's going to return us the value of this Gini impurity index. Okay, now the question is, how does the system, how does it help the system by looking at this Gini impurity index? Now, for our better understanding on this, let's go ahead and consider an example data set. So if I open up any example data set, okay, so let's say this is my data set, I'll call as X, and I have some Y. Okay, let's say, okay, let us consider some data set. I've got some for X, some values with me. Okay, and since we're talking about classification, I'll have as, let's say, uh, some in this manner. Okay, I have 4 rows belong to class 1. Okay, and so I'll say, yeah, I'll say 4 rows belongs to class 1, and I've got let's say, let's do one thing, let me just modify a few things. Okay, I've in this case I've got 4 rows where the value is equal to 1 or the class is equal to 1, and I've got 3 rows belongs to the class 0. Now let us understand, okay, how does this Gini impurity index will be calculated for this given data set. Now this is my given data. I have my entire data set. So when we calculate the Gini impurity index, so the idea is we want to construct the decision trees such that the branch, okay, the branch that has got the entries, all of those entries that are reaching a specific branch would belong to the same class. So that's the overall idea that we have got. Now from that perspective, I'll be interested in this column of Y, which is nothing but the target variable. So if target variable is of my interest, now let's go ahead and find the probability. As if I pick any random row, what is the probability that it would belong to a specific class? So if I calculate it, the probability of finding 0, if I pick any random row from this given data set, is given by 3 by 7, because I've got 3 rows which belongs to the class 0, and in total I've got 7 rows, and the probability of getting 1 is 4 by 7, because I've got 4 rows which contains class 1, and the total number of rows is 7. Now the entropy is given by 1 minus sigma of pi whole square, which is nothing but 1 minus 3 by 7 square minus 4 by 7 square. If you simplify this, I can get the overall output that says as this will be 49, 49 minus 9 minus 16. So this is nothing but 24 by 49. So this is the value of the entropy of this given data set. Okay, this is the value of the entropy, and we call this entropy of the given data set as basically as the entropy of the root node. We would call this as the entropy of the root node. Okay, now that you have understood about how we calculate this entropy, now let's take another scenario as what happens, okay, if I have every value belongs to the same class. If I have in the same way, okay, I'll consider another second use case. So here I'll mention the second use case as where every row belongs to the same class like this. Now in this scenario, the probability of getting 0 will be basically 7 by 7, which is equal to 1. Now if I calculate the entropy, that is 1 minus sigma of pi square. If I calculate it, this is 1 of p of 0 square, which is nothing but 1 minus 1 square. 1 minus 1 is equal to 0. That means here the entropy will be equal to 0 if I have all the rows belongs to the same class, and entropy will be closer to 1 if I have got the I guess here in this case the entropy will be equal to 0.5. Okay, if the if I have got the impure node. So that's the overall idea about measuring of the impurity. So the idea is when we give the data set, okay, whenever we send in the data set that is x and y for our decision tree algorithm, the system is going to find the values. Okay, the system will find the values of the entropy. I mean, the system will find the values of the entropy for my root node for the given data set. Okay, root node or the entire data set. Now it will try to split the data such that as and when it goes deeper and deeper, the entropy will get reduced. So that's the intuition in which the decision tree will be constructed. Now with this intuition, if you now take a look into the visualization, see on top, this is my Gini impurity index on my original data. Then I went ahead and I performed the split. And as and when it reached the point where it has been successfully split the data, the Gini impurity became 0. And you can see that they are all the leaf node. So the system will perform the split such that, okay, such that the overall entropy in my given data set will get reduced. So that's the overall idea about the fitting of this decision tree algorithm for the given data set. Now this is the Gini impurity index. I'm sorry guys, I think, yeah, this is a Gini impurity index that what we have seen. Okay, so if I talk about the entropy will be a different equation. It's like what we have seen is a Gini impurity index. Now if I talk about the entropy, okay, so entropy is another loss function. Now entropy basically it's a measure of randomness in a given data. Okay, so if I say entropy loss function, this is given by p of I into log of p of I, that is true class distribution multiplied with the predicted class distribution, and this will help me to find the value of the entropy for the given data set. So just like we calculate the Gini impurity index for the root data set that is on the entire data, and then perform the split such that we'll be reducing the value of Gini impurity index. In the same way, we can make use of the entropy and continuously split the data based on the splitting criterion and split it continuously. So that's the idea about this entropy. So we can either make use of the Gini impurity index or the entropy. These are the two most commonly used loss function whenever we are implementing the decision tree algorithm. Okay, apart from that, we also have another loss function that we can use that's called as a log loss. So these are all the various criterion that we can use it. Depending on this specification of this hyperparameter, the overall fit of the like overall fit of this model will take place. So that's the overall intuition behind this decision tree classifier. Okay, so is it clear so far, team? Please confirm. Thank you, Karthik. Thank you, Dheeraj. Thank you, Lakshman. How about others? Is it clear so far? Thank you, Sampriti. Excellent. Thank you, team, for confirming. Okay, there are some more questions. Thank you, Josie, and thank you, Saurav. And I see a question from Shripad. So, what value is the goal of entropy? So, like here, the goal of this entropy is to reach zero. Okay, so the entropy will be maximum when we have the lot of, like, when we have entropy will be maximum when we have random distribution of the data. The entropy will be minimum uh, when we entropy will be equal to zero when like when we have a pure node. So that's the intuition here, Shripad. Okay, any other questions, team? Great. Okay, let's proceed ahead. Okay, so let's proceed ahead now that we have understood about this. So now the next question that comes to our mind is, when we have fit the model, when we have performed the fit for this given data set, okay, so we have basically like made use of all the values, and what we can do is, okay, so in this given data set, so we have performed the fit for the given data. And yeah, so yeah, I think it's already explained. Yeah, we have also made use of the grid search CV algorithm. So so I think with this intuition behind us, so we have covered an important aspect that we need to remember from the perspective of this decision tree classifier. Now, apart from that, we also have other hyperparameters in this decision tree classifier, that is minimum sample leaf, minimum sample split, maximum depth, and so on. So we can consider these hyperparameters and perform the fine tuning so that we can get the better performance of this decision tree classifier. Okay, so that's the activity that we can do. Now, the question that comes to our mind is, okay, so now that we have a trained model present, okay, so how can we go ahead and generate the prediction? Or what would be the next step that we generally do? Because all the learnings that we had so far, we have prepared the data set, we have performed the fit, and after the performing the fit, we went ahead and uh, like okay after after this done, okay, we went ahead and performed the fit and generated the train model. Now the question is, what is the next step, or how do we generally approach the machine learning task after the fit is performed? So here, to understand this, there are some few things that you need to understand. One is serialization and deserialization. That's an important concept that you need to understand. And apart from that, you need to know about how to generate the prediction on new data. Okay, so these are the two things that you need to remember. So let's understand about this concept of this serialization and deserialization. But before we go over there, I see another question from Shripad. Shripad says as, how does entropy formula add to zero? Okay, sure. Let's do one thing. Let's consider the entropy formula that we have got. So when we consider this entropy formula of this decision tree, so this is given by, this is given by P of I multiplied with log of predicted class distribution. Okay, so now uh, okay, so here when we look into this true class distribution and the predicted class distribution, so here think of it in this way. So we will look into the, let me see if I have an example calculation right here that would basically simplify a bit, or else we can take a look into it at a later point. Okay, so let's consider an example. Okay, let's consider an example. So I'll, like, for the better understanding of this entropy, we'll consider two things. Let me bring up a notebook. So let's say that uh, okay. So let's consider. Okay, generally whenever we are looking at the probability, okay, we'll be doing it in this way. Okay, let's assume that uh, my probability score, okay, let's say my expected probabilities are 1 and 0. Okay, so the way that we would use it whenever we are thinking about the entropy is, so let's say this is my y true. Okay, so if I have two classes, let's say 0 or 1, so we'll generally represent it as like one hot encoded, where we'll say this as, okay, 1 which means that it belongs to class 0, and here if I have 1, it would mean that it belongs to class 1. So 1 and 0 means that, okay, this is referring to the uh, correct distribution. So I'll be mentioning in this manner. Okay, so your y true is given by 1 and 0, which means you're expecting the target prediction to be 100% for the class 0 and 0% for the class 1. But when you're generating the prediction, let's say the overall prediction is given as, okay, overall prediction is given as, let's say 70% and 30%. You've got 70% of the rows belongs to the class 0, and you've got 30% of the rows in that branch belongs to class 1. Okay, this is like an impure node scenario. Like, think of it as you've got 10 rows. Okay, and out of this 10 rows, 7 rows is having class 0, and 3 rows is having class 1. Now you are predicting, okay, you are predicting over here, this is the 7 and 3, but in reality I'm assuming that, okay, all these, if I'm thinking this node over here is going to determine as class 1, the white row I'll mention as 1 and 0. Now, let's go ahead and calculate the entropy. The entropy is given by P of I log to the base 2 of, uh, like here it is P of I. Let's look into the formula again. So here the formula says that, okay, P of I, that is true class distribution, multiplied with the predicted class distribution. So here in this scenario, the true class distribution is, let's say, since we're dealing with class 0, so this is 1, true class distribution is 1, multiplied with predicted class distribution over here is 0.7. Okay, plus true class distribution for class 1 is 0, multiplied with log to the base 2 of, let's say, 0.3. Okay, now if I go ahead and simplify this, let's calculate the value. Okay, log of 7 of 2 base 2. Okay, this is log base 2 of 7 is 2.08, 2.80. That is what we would get. So 1 times 2.80 plus 0. So we are getting the value of, I think I don't think so that's the correct one. Let me recheck again. Think let's recheck once. Let's look into the calculation over here. It's log 2. Okay, I'm guessing that's the log 2 only. Yeah, so we would go ahead and calculate this log 2. Okay, log to the base 2 only. So might be, okay, it's 0.7. I think I was calculating incorrectly, guys. So 0.7 to the base 2. Okay, then we'll be getting the correct answer. It's minus 0.51. Okay, the formula that we have got is minus of pi, right? So it is minus, okay, minus 0.51. So which is nothing but 0.51. Okay, so I'm getting the value of entropy as 0.51. Okay, I'm getting the value as 0.51. So at the max, okay, this log will be maximum when I'm getting the probability as 0.5. So if this is 0.5, this will be minus 1 times log to the base 2 of 1 by 2 minus, and this will be log to the base 2 of 2 power minus 1. So this will become minus 1 times minus 1 log 2 to the base 2. This will be equal to 1. So the entropy will be maximum when the probability is equal to 0.5. Okay, so this is how we'll be calculating the entropy. Okay, this is how I'll be calculating the entropy for the given data set. So by comparing with the y true probability with the help of my ypred, so we'll calculate the entropy, and the entropy will be maximum when the value of p is equal to 0.5. So that's how we'll be calculating. Okay, any other questions, team? Okay, thank you, Sripad. Okay, so let's move on to the next topic, that is serialization and deserialization. So serialization is a fancy term that we would use it to say that we are going to save the trained machine learning model into a file. So in order to perform the serialization, so we can make use of a module that's called as joblib. I would make use of this joblib library in order to perform this activity of this serialization. So let me just show you as well as how we go ahead and use this joblib and save the model. So here, in order to save the model, we'll say joblib dot dump, and we will specify the file name. I'll say final underscore model dot joblib. You can mention any extension. Just for the demonstration, I'll just mention as dot joblib, and we'll have to mention the file name. Okay, the first is basically the value that I want to save. It's the best model. I'll say best model comma final model dot joblib. So now if you look into the Explorer, see there's a file that has been created, which is basically a joblib file, and this contains the trained model file. So this basically contains the trained model file. Now, since I have serialized the model, now if I'm creating any code, okay, if I'm writing any code, then in such scenarios, if I want to load the saved model, So I can say load model, like I'll just show you with an example. If I want to perform the deserialization, I can now simply say joblib.load and mention the file name. Now in this way, I can load the saved model file. See, now if I display my load model, so the model that got loaded, this is basically the decision tree classifier model, which I have performed the saving earlier. This is called as a deserialization. So serialization is nothing but it's going to help us in saving the model into an external file, and deserialization will help me to load the saved model. Okay, it would help me to load the saved model from the external file. So once I perform the serialization and deserialization, so now that you have this idea, now what you can think about is using this saved model whenever you have got a new data. Since this is a decision tree classifier that has been trained, let's assume that I've got a new data. Now for the demonstration of new data, let's assume the X test that we have got as a new data itself. Now on this new data, you can just go ahead and perform the predict on this new data. Then that would help you to generate the target, that is nothing but the output. So the process that you would follow is you will go ahead and perform the training. Now perform the hyperparameter tuning. Now once the hyperparameter tuning is completed, you will save the model into an external file. Now once you save the model into an external file, you can then go ahead and use that saved model and use it in the further part of your application. So that's a process that we generally follow whenever we are working with this decision tree classifier or any machine learning model in general. Okay, so that's the idea about this, the serialization and the deserialization. Now apart from this, now one more thing that you need to remember is, especially when you're working with this decision tree model, is this decision tree model tend to overfit on the given data set. So you always have to be mindful about this fact that it will tend to overfit. So you always have to monitor the various metrics on the test data, and this would ensure that you're going to have the model which is a balanced one. Okay, so this was about the detailed discussion of this decision tree classifier and how do you generally implement it. So I will go ahead and share this file over here on the hands-on machine learning page. So you can download the source code from there. Let me just share it everywhere. Okay, I've shared you the link over here on our social media platforms too, so that you can refer to this link. That's the same page that I've shared earlier. You can upload the updated code from there. Let me upload the updated code so that you'll have an access. Okay, team. So I've just uploaded the file in this website. So you can check the page over here. There's a new file that has been added, that is updated decision tree classifier, and you can download the code from this page. And we'll also be attaching the recording once the session is completed. Okay, guys. So this was about the chapter 6 learning that we had in this learning journey of this machine learning. Okay. Now, any questions on the discussion that we had so far? So please do let me know, guys, before we move further in our learning journey. So if you are clear so far, please confirm by typing in as all good. Okay, thank you, Darshan. Thank you, Dheeraj, Diksha. Thank you, Shripad. Thank you, Lakshman. Okay, so let's proceed further, folks. See, if we move on to the next chapter in this hands-on machine learning, so the next chapter is about the ensemble learning and the random forest. So let's have a high-level idea about what exactly is this ensemble learning, and we'll discuss in detail in our next session. Okay, we'll have a high-level introduction to this ensemble learning. So if you look into this chapter, okay, so it basically talks about the various ensemble learning algorithms. We've got voting classifier, we've got bagging classifier, you've got the random forest, boosting, and stacking. But before we dive deep into those kind of classifiers, it's very important that you understand the basic. What exactly is this ensemble learning? Now, ensemble learning is basically a technique where we are going to combine multiple machine learning models. Okay, we'll combine the multiple machine learning models to generate the prediction or to learn the pattern in the data set. So it's a special kind of scenarios where we are going to use the multiple machine learning models to find the patterns in this given data set. Now, this basically works on the principle of wisdom of crowd. So the idea is, okay, if you have any complex question, okay, suppose if you have a complex question and if you pose this complex question to thousands of random people, then if you try to aggregate their answer, in most of the cases you are going to find the aggregated answer is better than the single expert's answer, and that's called as the wisdom of crowd. In the same way, if you aggregate the predictions from the group of predictors, like it can be a classifiers or it can be a regressor, depending on the task that you're trying to solve, you're going to get the better prediction or the better outcome with the combined models than the single best individual model. Now, this group of models or predictors, we call it as the ensemble. And hence, we call this overall technique as the ensemble learning. Now, when we talk about this ensemble learning, there are various kinds of ensemble learning. So let's understand each of them. So I'll take you to the notes which I've got. Okay, so let's understand about the various ensemble learners that we have got. Okay, so here, first kind of ensemble model that we have got is called as the voting classifier. So let's understand about this voting classifier. Now, think about it in this scenario. Okay, suppose you have trained the models. Suppose you have trained few classifiers, and let's assume that each of this classifier is achieving, let's say, close to 70 to 80% accuracy. Let's say I'll consider a very simple classifiers. Let's say logistic regression classifier, and maybe you'll have some kind of an SVM classifier, and let's say there is a decision tree classifier. Okay, so maybe you'll have other types as well. Let's say you also have, let's say, KNN model. Okay, K nearest neighbors classifier. Okay, like this you have trained multiple models. Okay, now what you will do is, a simple way to create a better classifier is to generate the overall prediction. Okay, to generate the overall prediction, you will consider the output, the prediction from each model. That means you will check what is the prediction from this model, logic regression. Let's say it will give me the giving the prediction as class A, SVM is giving you the class A, and KNN model is giving you class A, and let's say decision tree model is giving you the class B. So instead of going with the individual model, now what you will do is you will consider the predictions from multiple machine learning models. Now, once you've got the predictions from multiple machine learning models, you will go with the output which has got received the maximum number of votes. In this case, class A has received the more number of votes. So I would say class A is the one, is the overall output as a output from this ensemble model of this voting classifier. So in the case of this voting classifier, what you would have is you will have the multiple models. Okay, depending on depending on the model, depending on how the overall prediction, the maximum number of votes that it has got, that would be the overall output from this combined voting classifier model. And this is called as the voting classifier, or the ensemble method of this voting classifier. And like this, we also have the other classifiers such as bagging, random forest, boosting, and stacking as well. So we will learn about all these things as we progress in our learning journey, that is in our next session, guys. Okay, so I'll be attaching this notes as well as and when we progress in this learning journey. All right, team. So with this, I think we'll say we can end the today's session here. The reason is with the new chapter that is starting in, so it would be better if we discuss it separately in the next session so that you'll have a continuity in the learning journey. So, folks, I just want to let you know about the new upcoming live session with Manifold AI Learning. So, this is an intermediate course on LLM Ops, AI Ops with AWS. So this is a 30 hours course. So previously it was 20 hours. Now it has been upgraded to 30 hours, where you will be learning some of the industry in demand skill set right now, where you'll be learning about generative AI, how to work with the AI ops, the how you can deploy the machine like the generative AI models on the AWS, and how to make use of the SageMaker pipeline, which is in line with the current industry's requirement. So this is a limited learner batch. So do check out the link over here for the registration. So this is a, as I mentioned, this is a limited learner batch if you're joining in. So do register fast, because once the learnings, once the batch is full, so the new learners will not be able to get onboarded. So there are two options for you. So option one is 6 a.m. to 8 a.m. IST, and option two is 9 p.m. to 11 p.m. IST. And the batch is starting, the orientation session will be on 23rd of April. The first session is going to start on 24th of April 2024. Okay, so do check out this page for registration. And as I mentioned, it's a limited learner batch. So make the most of the same, guys, if you're planning to join. And I look forward to seeing you next time, everyone. So if you have got any question, please reach out to support at the rate Manifold AI Learning. So they'll be able to assist you with any of the queries that you might have with the admission process. Okay, and if you're someone who's looking into the self-paced learning path, yes, I highly recommend you to check out the course on LLM ops generative AI course, so where you will be learning about how to work with chat GPT and how you can deploy it on the Kubernetes cluster, so which is also another great way to deploy. So you can also check out this course as well. So I really wish you all the very best for your upcoming learning journey, guys. Now, if you have got any questions, okay, on any of the query, any of the topics that we have discussed till now, please feel free to let me know. Okay, so if you're clear, so please confirm by typing in as all good, and I look forward to seeing you next time. So you can check the page of this hands-on machine learning page. After 1 hour you'll be able to access the sessions recording as well. Okay, and folks who are trying to joining in for the live session, so we have a support team of manifold AI learning on call, so they'll be able to assist you in case if you have got any questions related to the joining for the course. Okay, they'll be able to answer. I'll be here for another minute and then I'll be dropping off, so the team from the manifold AI learning will be there to answer any of the queries that you might have during the admission. Okay, thank you, Diksha. Thank you, Dheeraj. Okay, that's great, Sridhar. Yeah, you can reach out to the support team. They'll be helpful for you. Okay, any other questions, team? And for the folks who wish to interact with the Manifold AI Learning admissions team, I'm sharing you the link. You can join that link and get your queries resolved regarding your admission. Okay, so that's great, Sridhar. Yeah, I look forward to seeing you on the live session then. Okay, so that means you have taken a slot. That's great. Okay, thank you so much, everyone, and I hope to see you next time. So I've pinged the link in case if anyone wants to speak with the admission team. Okay, take care, guys. I'll be ending the stream, but I'll be there on the webinar for a few minutes.